And so a lot of times this happens when you'll have one page that serves up another page, and so the custom error page will be pulling information from another source, and so the first page will have a 200 OK, and then the information will be pulling from another page, and it may be getting another server, and it may get some other error, the signature will just be looking for that 200 OK because it sent the request for search.pl, and so it is looking for search.pl, and the mechanism it uses to detect that is, hey, did I get a 200 OK for that? And the first page provides that 200 OK, but that page is just like a wrapper, and so a lot of the false positives are that way as well. Response timing is a lot of the blind SQL injection attacks that the vendors use now. Just send a wait delay, and depending on the network and depending on the application, you're going to get potential delays that look to be the same. And so a lot of times, just because of if you don't the scanners have configurations to where you can send a lot of threads and you can send a lot of attacks. So using the timing is not a very good mechanism for doing that, because you can't control necessarily all the variables. And so timing responses lead to false positives as well. And this is actually kind of already touched on this, is that the scanners at least in the non-expert mode where you haven't set up custom error page detection don't have that there, and so they're going to basically they'll go and grind for pages and looking for different examples like a backup version or some older version. They'll go through, and as long as they get that 200 OK, that's the most sophisticated that mechanism ever gets. And so anytime it gets back at 200 OK, it's going to say that vulnerability is there. And we've also had in the target just had text of the number 200, and where the signature isn't even looking for the OK as well. It just goes off on the 200. And so for having 2008 in the body of a page, like in search PL, if it's looking for that, and in that search page there was 2008, it would trigger based just on the 200. I mean, it's hard to believe, but some of these signatures don't have any real sophistication involved in them, and have that type of problem.
With most scanners, it seems they allow you to configure a custom 404 response, so that if you are returning 200 OK for a 404, you can configure that into the scanner so that you won't get those false positives.
Certainly, that's part of the expert configuration, but for a lot of users, they don't actually do that, and ultimately, that's something we can't control. We can't. So thinking of kind of like the scientific method, and you're trying to figure something out, you want to try to control as many variables as you can. The one thing we can't control is how expert the user is, so that's why we choose the default configuration. And so to some extent, there is you can get away from having as high false positives by doing the custom 404 as the main feature there. That would allow most of the scanners to do that. And so that decreases some of the false positiveness, especially the really unsophisticated ones that are only looking for a 200 OK. But in some of the other, open source, they don't have that ability to look for custom 404. So it's definitely something that's needed, but it's also not sufficient as well for some of the signature bases. Because I've seen depending on the type of setup that you have, because sometimes you have multiple pages that depend on they're pulling content from multiple different locations, and so it's the scanner is getting back multiple 200 OKs, and so I mean just the complexity on some pages will fool the signatures even with a custom 404, because you may be getting a custom 404 from one part of the app, and then another part of the app that's actually another server is sending its error pages that don't have a custom 404 wrapper. So, I mean, a lot of times those are corner cases, but yeah, it's definitely the first thing you should do in expert configuration. The pre-existing trigger one is actually the content in the HTML itself will trigger a false match because it's just looking for a string. So example of like social security numbers or credit card numbers or something like that. So a defined string of content, or the looking for of a privacy document, or so that there's a bunch of different signatures that look at that stuff to where it's based on the content in the page, and they haven't tried to define it more. So like a 9-digit string of numbers is interpreted as a social security number. So just give it a second to glance over that. Then here's another one I've actually somewhat talked about already, is that like the detection of the vulnerability requires maintenance of state, but the target actually doesn't have that in there. And then here's another one that when some applications will take a request and end up rewriting that request and forwarding it on to another part of the application. And so you get, so sometimes they'll stick that information into cookies or parameters. Actually, it looks like I'm running out of time, so I'm going to actually fast forward through that stuff. Here's a look at just the ORB target, and so it has like a fake login, and then it also has a submission page and stuff like that that rewrites the request to the body. And so actually, I'm going to get to the results now. And so this time we took two popular black box web application scanners, both of them commercial, where before we had 3 commercial and 1 open source is our benchmark. But ultimately we couldn't get reliable results out of 2 of the previously tested products. Every time we ran that product, it got a different set of results. But ultimately the 2 products did say. And so here's just to go back over the 2007 results. Like one of the scanners, which was actually the one that was least amount of time in the market, generated 92% of the total findings and false positives. So it had false positives in the thousands, where the other ones were grouped closer together in times. And so ultimately, there was 9,000 something false positives in total, and that's just another breakdown. We ultimately, we'd run the scanners against the target and then break up the vulnerabilities into categories. Those categories with path manipulation, command injection, cross-site scripting, SQL injection, file or information disclosure, and then CVE